So again, one more time. Today, we're going to learn about the properties of a normal distribution curve, as well as be able to apply it to some applications, and hopefully, again, having a better understanding. Now, data, whenever you give some data, it can be distributed, spread out in different ways. As you see in these three bar graphs, you can see that the data could be spread more to the left. In the second graph, you can see it being spread more to the right, or it can be jumbled up, okay? If you think about it, if some data is spread more to the left, that means like more of your data lie in those higher values, okay? So like you have more values that were in like the 100, 120, 140 range, okay? And not so many in the 40, 60, 80 range. Does everybody understand that? So if I like had 100 pieces of data, then maybe like 70% of the data lied in the upper range of that. Does everybody understand what I'm saying? As being more spread to the right, and more of your data is on this end versus this end. Vice versa. For the second graph, you have more to the right, okay, so you have more values that were smaller versus bigger, or it could be jumbled up, okay, random data that's collected, okay? However, in many cases where data tends to be around a central value, no bias left or right, it is close to a normal distribution that looks like this, the bell curve. Now, I did show this to you guys yesterday, the bell curve. We're going to be talking again a little bit more in depth about it. This right here represents a normal distribution. And as you see, basically, a normal distribution curve is created from basically like old school bar graph, taking the top values, taking like the top points and connecting those to create it. Does everybody see that? Because if you look, he's hitting the top of each one of those histogram bars. Okay? Questions so far of what it's going to look like. Now, the number of standard deviations from the mean is what's called either a standard score, sigma, or the z-score. You do need to get familiar with these words because they're going to ask you things like, what is the z-score? And you have to know that they're relating to a point on your actual graph. Now, what you see here is your basic standard normal distribution curve, your standard normal distribution curve. And if you notice, it's kind of broken down into intervals, okay? This center line represents your mean, okay? The next set of lines, where it's 1 and -1, represent the mean plus 1 standard deviation, and the mean minus 1 standard deviation, okay? And what you should see here as well is that whatever your mean is, if you're within 1 standard deviation, 68% of your data lies in between those two values. Okay? 68% lies in between one standard deviation. Okay? Here, the next set of intervals, this will be your mean plus 2 standard deviations. Over here, your mean minus 2 standard deviations. And if you were to add up each one of these percentages, each one of these sections, 13.5, 34, 34, 13.5, you get a number. That is what? What is that number when you add up all of those? What is that number? Huh? No, it's not 100. Was 13.5 it's 95. So that means that out of your data, 95% of it is going to lie in between this second standard deviation. Okay? The last one, you notice, going in a pattern. This last interval is your mean plus 3 standard deviation, or your mean minus 3 standard deviation, okay? those intervals are broken down 2.5, 13.5, 34, 34, 13.5, 2.5. How much is that? Try again. Are you sure? Positive? Okay. All right. So, 100% of your data is going to lie between 3 standard deviations of the mean. What you should also notice is that this curve is symmetric, okay? So 50% of your data will lie below the mean, 50% of your data lies above the mean. If you think about it, mean means what? Average, okay? Halfway. So this value is halfway between all of your data that you're given. Half of it lies below that center line and above it, okay?
Is there always 68?
Yes, it's always those values, always those percentages. But there you go, that's your standard normal distribution curve. Now, to apply this into a couple of real world situations. Now some of these may be, you're like, okay, well when will I ever use something like this? Well, let's think of it like this. When they create EOCs and all these standardized testing and then they come up with a score that's considered passing, they take the very first group that does the testing. Okay, so in our case with Algebra 2, you guys are the first group to do the Algebra 2 EOC. They're going to collect all the data. They're going to basically find the average, and then they're going to find the standard deviation. And then what they're going to do is they're going to calculate, they're going to calculate the numbers that are going to be, these are going to be the numbers, this is going to be the value that's going to be passing. They use standard deviation and mean normal distribution curves to actually figure out what value is considered passing, okay? They actually do that. So, a lot of teachers will say don't try to aim high so you know it's not like a super high score, but I mean, I don't want y'all to aim low either, okay? We want to pass, just put that out there.
So we have a better chance of passing because we're the ones who set it.
Exactly. So you guys are the ones that are setting the pass or fail.
So what if we were like the smartest class and because we got really nice scores like in
Well, it's not our class. It's not just our class and it's children's classes. It's everyone in the state of Florida who's taking Algebra 2 this year. So it's kind of it's everyone all together. So if you got some super brainiacs in the northern part of Florida, we're on the lower end. Then it's kind of like you see we're getting there, or vice versa. Yes. Oh. So let's look at some examples. It says the weight in pounds of newborn calves on a farm are distributed normally. So that right there is going to let you know there's going to be a normal distribution curve with a mean of 85 and a standard deviation of 4. What percentage of newborn calves on the farm weigh between 77 pounds and 89 pounds? Sketch the curve. Hint, you have 6 equal parts, okay? So because this information is normally distributed, we know it's going to be a bell curve, okay? So we have our horizontal line, which represents our x, okay? This is going to be where the pounds are going to be located, okay? 77, 89, 85, so on and so forth. And then we're going to have our bell curve. Your bell curve is not going to be perfect, it's not going to be symmetric, but just do the best that you can, okay? And at the center, in the middle, that is where your mean is, okay? And in this case, our mean is 85, all right? Now, you guys have it kind of nice because you have that graph right there above this example, and so you can see the 6 equal parts, right? You have your first standard deviation, which makes up what percentage? 68, okay? And remember, to find this value right here, you have to add the standard deviation to the mean. Well, if the standard deviation is 4, you're going to do 85 plus 4, which is 89. To get this point on the left side of the mean, what do I have to do? 85 minus 4, which is 81. So this right here tells us that between 81 pounds and 89 pounds, 68% of our data, or 68% of our newborn calves are going to be in between that weight. That's what that tells us here. Okay? What about our second standard deviation?
You have to add 8 to 85,
93. Okay? So our mean plus 2 standard deviation. So 85 plus 8, which is 93, you said? Okay? You can also do it, just continue to add the standard deviation to the previous standard deviation. It works the same way. Over here, we do our mean minus 2 standard deviation, which is what? 73?
Oh wait, 77.
77. So now this tells us that from 77 pounds to 93 pounds, 95% of our data lies in between those two values. Last, a third standard deviation. We do our mean plus what?
3
standard deviation, or 12. So what's 85 plus 12? 97. And on the other side, we do our mean minus 3 standard deviation, which is 73. Okay? So from 73 pounds to 97 pounds, basically all of our data lies in between those two values. Now, do not get me wrong, there might be that one outlier of that really super big calf that came out, okay? There are the potential for outliers. However, if there's just one, it's not going to change your spread drastically, okay? Questions on the actual graph, creation of it. Okay? So again, we have 34% here, 34% here, which basically makes up 68%. Here was 13.5, 13.5, then 2.5. Okay, there's the breakdown there. So when it asks us what percent of newborn calves on the farm weigh between 77 pounds and 98 pounds, exactly, it's asking you for this part right here. And to find it out, you add those percentages, 13.5, 34, and 34, and you get what? 81.5? So 81.5% of our newborn calves weigh between 77 pounds and 89 pounds. From the normal distribution curve, remember within one standard deviation is 68%. And since the mean is basically like that symmetric point, it cuts it in half, that's where the 234 came from. The 68 divided by 2. Okay? Now we're going to continue to use this graph to find the percent of, I don't know what that says anymore. Calf weights within each interval, okay? So between 73 pounds and 81 pounds, what percentage of our calves' weights lie between those pounds? 16%. Because all you do is you add the 2.5 and the 13.5, because that's where 73 was, that's where 81 was. 2.5 plus 13.5, 16%. Greater than 81 pounds. What percentage of our calves were greater than 81 pounds? Said 84. How did you get 84? That is one way you could do it. And that's another way you could do it. Since we already know how many weigh less, basically from 73 to 81, we can easily do 100 minus this, which is 84, or we can again just add the intervals. Either way would get us 84%. of our cast weight between 81 pounds. Questions so far? Try and take this slow. Just make sure everyone's understanding. If you're not, let me know. Okay? Take a minute, try to figure out 3, 4, 5, and 6. Okay, what was the percentage from 77 to 97? 97.5, very good. Less than 85 pounds? 50%, because think about it, 85 was our mean, so yes, 50% less than it. At most, 89 pounds. Say again? 84. Very good. At most, that means that we know up to 84 pounds, 89 pounds. And at least 93 pounds. I have some conflicting answers. I hear 97.5 and then I hear 2.5. Which one is it and why? And why? Because at least, that's the least amount, okay? So I'm just talking from here and bigger. So yes, 2.5. Questions on drawing the curve, finding percentages. Here's another one. It says, what is the standard deviation for the normal distribution shown at the right? Yes.
60.
How'd you get that?
You can either take the median and subtract it from 616, or you can take 736 and subtract it.
From what again? What'd you call that?
The mean.
The mean. Yes. Does that mean that center value, okay? This is one standard deviation. So yes, you can either subtract these two here, or subtract these two to figure out what your standard deviation is. And so 736 minus 676 is 60. So our standard deviation is 60. Questions?
Would that be the answer that we would get if we added it all up and got the mean and then subtract another from the mean and squared it and then divided it by the number of terms?
And a multiply by number of terms, and then took the square root. Yes. And then took the square root. Yes.
Of those numbers?
No, this number. This is the number that you would get if you did that whole process.
Those numbers or the different numbers?
No, with different numbers.